Okay, so for this talk, it's going to be a little different than you're used to. Cell phones are actually required. So you can go ahead and get out your cell phone. Turn the ringer off. That part is the same. Because we're going to do something fun. I'm going to actually ask you questions and you're going to be able to answer them on your cell phone. So all you have to do is you have to text Texas Tech to that number. It has to be all caps. It has to be one word, no spaces. If you do it right, you're going to get a message back saying that you're part of the live polling. Is anybody successful? Mm-hmm. Yes? Mm-hmm. Okay, I see some nods. All right. Yeah. What did your message say?
We know that you're first-time participant. Your phone number is completely private and we will never spam you. You've joined Catherine Hayhoe's session. When you're done, reply leave.
Excellent. Perfect. So that's the message that you should be getting if you did this right.
Is it case sensitive? Do we have to do caps?
I believe.
It's not.
It's not. Okay, she says it's not. Okay. Anybody else? Who else is in? You in? Okay. Good. A lot of people are saying it's optional. I'm not counting you. It's totally anonymous, so I don't know who you are. So if you don't want to do it, that's fine. It's just kind of fun to do. Okay. You will know when to answer because we will get to a slide that has some poll results on it. We are talking about what I study, which is climate change. And here comes your first question. You ready? Here's the first question. So get out your phones. All right. And I'm going to ask you, there we go. What this does is this has some answers on it from last time. So we're going to combine our answers from two different classes. The same topic. Do you believe in global warming? Text A for yes, B for no, and C for I'm agnostic. Don't forget to hit send. Excellent. Oh, good. We have some results coming in. Isn't that cool? You can actually see it change on the screen.
Is this poll everywhere?
Yes. Yeah, I love poll everywhere too. They sent me polling socks for Christmas.
How did you get them?
Yeah?
It didn't give a little confirmation like it did the first time.
No, I think you only get the confirmation the first time.
Okay, thanks.
Okay, everybody locked in their vote? All right. Your answer is completely anonymous. I don't know who texted what, but I'm going to tell you my answer. And when I am asked, do you believe in global warming? My answer is, no, I don't. Why? Because it isn't a religion. As Lindsey Graham said a couple of years ago, he said the problem is that Al Gore has turned this thing into a religion. What is the proof of that? The proof, we just have to go to the internet. The proof is right here, and if you have very sharp eyes, you will see that somebody actually went and photoshopped my head onto one of the members of the choir. No, I do not believe in global warming because science does not demand belief. Did this horse believe in gravity? Doesn't matter, does it? You step off the cliff, you're going down. Does it matter what we believe about what a bunch of thermometers are telling us? No, it doesn't matter what we believe. We need to look at the evidence, and we need to make up our minds based on the evidence we see, not on whether we believe or don't believe something that somebody has told us. So that's what we're going to do today. We are going to look at the evidence together. And we're going to start, first of all, by defining what exactly is climate. It is not what happens on a certain day in a certain place. That's weather. It's like a single tree in a forest. Weather is like the single day. It's super hot, super cold, very wet, very dry, crazy tornado, dust storm. That's weather. We're not talking about a single event. We're talking about the whole forest. We're talking about what happens every single day for years and even decades. So when we look at global temperature, people often say, yeah, but okay, you can look at thermometers all around the whole world. And when you look at thermometers all around the whole world and you add them up, if you look at, this period here from about 2000 to about 2012, it wasn't really going up. So there's a lot of articles in the news saying, it wasn't really going up. What's the big deal? But what is the definition of climate?
Long period of
Long-term
time.
average over at least
30.
20 to 30 years, exactly. So this is a little bit too short. We have to fill in the rest of the data. And we have to fill in the rest of the data, and the rest of the data, and the rest of the data. And when we do that, we see, no, actually, from year to year, global temperature can go up and down. But over climate timescales, it is going up. And then people say, well, how can you trust those thermometers? Because you know those thermometers, they're based in cities often where you build lots of buildings and they get really warm just because of the urban heat island effect. Well, you can look at what's happening not in cities. You can look at what's happening up in the Arctic. You can look at what's happening out in the middle of somewhere where there's no cities. And in fact, if anything, it's warming faster where there are no thermometers in cities than where there are. It isn't just about the thermometers either. I mean, if you throw out the thermometers and you simply look at what is happening in the places where we live, if we live up in the Arctic, what used to be permanently frozen ground is thawing and crumbling. If you live in Australia, they've had record-breaking heat waves where they've had to add new colors to their temperature maps. That in the middle there is 54 degrees Celsius. Anybody who knows Celsius knows that is crazy. It's like over, what is it, over 125? Almost 130. We know that hurricanes are not getting more frequent, but they are getting stronger because they get their energy from warm ocean water and the oceans are warming. And we know that invasive species that used to be kept at bay by cold winter temperatures are moving northward. And one of the invasive species that have moved into our area right here are fire ants. Fire ants are an invasive species. They were introduced to North America, but we didn't used to have them here in Lubbock because it was cold enough in the winter to kill them off. But our winters have been warming faster than any other season, and we have fire ants now right here in Lubbock. One of my colleagues, Dr. John Zach, who you may know if you are in biology or take biology, one of my colleagues, being a biologist, started to write down the day that the peach tree in his backyard flowered every year since he first moved here. He's lived here for 30 years, and when he had to cut down the peach tree in his backyard, and he just lives, about a mile or two west of campus, when he had to cut down that peach tree, it was flowering 3 weeks earlier on average than when he planted it 30 years ago. If we look at the climate of Lubbock now, it looks exactly like what Austin looked like about 25 years ago. Already. Now, unfortunately, that's just the climate. It's not the music. It's not the restaurants. It's not everything else. Hopefully that will come too. Just the plants for now. So if you throw out all the thermometers, if you throw out all the satellite instruments, if you throw out all the scientific observing systems, and all you do is look at what is happening in people's backyards, all around the world, you know how many different independent lines of evidence we have that the planet is warming? 26,500 independent lines of evidence that people have added up. That is a lot of information. So is climate changing? Science says, yes, it is. But now we get to question number 2. This one's a tougher one. Why is climate changing? Because climate has changed in the past, right? It has. Why has it changed in the past? Get your phone ready. Ready? Okay, get the phone ready. And what I want you to do is I want you to actually enter a reason. I want you to enter a reason why we know that climate has changed. Now, it doesn't have to be these reasons here. Enter your own. See, isn't this cool? When you enter your own reason, it changes. If you enter something that's already there, it gets bigger. If you enter a new word, it gets added. Isn't that cool? So add a reason and then push send, and you will see your words up there. Now, unfortunately, if you do 2 words together with a space, it separates them.
I'm sorry, as you put 2 words together, it separates them?
If you put 2 words with a space in between, it will separate the words in the wordle.
Okay.
But this is pretty cool, isn't it? Do you see what you put in there up there?
Concentration.
Excellent. It's there. All right. When we look at this planet, we know that climate has changed in the past, right? We know because we've had changes in energy from the sun and we've had natural cycles, and we also know because everybody has watched this. Now, this is just for fun. Here we go. Ready? How many times have you watched an Ice Age movie? Have you watched it? A, never. B, once or twice. C, way too many times. And D, what are you talking about? Let's have your answers and be very honest here. Oh, the never. Wow, the nevers are moving up. Who are you people and where do you live? Once or twice. Way too many times is still. Oh, once or twice and way too many times is winning. I mean, the once or twice people might be the same as the way too many people. Just depends on how tolerant you are of Ice Age movies. Oh, once or twice is winning out. Okay. So just so you know, you might not know this, but once a month at the Alamo, we have Climate Cinema. It costs $5. It usually sells out, so you want to buy your tickets ahead of time. Follow our Climate Science Center page on Facebook if you want more info. And once a month, we have Climate Cinema at the Alamo, and we show movies that have something to do with climate, like Ice Age. We really do. Or like the movie where they get in that train and they're circling the globe and the whole globe is covered in snow. Like that movie. We also do some documentaries that actually have real information and facts in them. We did the one, Children of Men, where people can't have children anymore. Do you remember that one? We just did that one, and we had a demographer speak afterwards. We always have a little talk afterwards. So if you're interested in movies, check out our Climate Cinema. But we know that climate has changed in the past for totally natural reasons that have nothing to do with humans, right? I mean, humans cannot control the sun, and we cannot control natural cycles. So when we see that the planet is warming, we have to say, okay, could it be one of these that's causing the planet to warm? All right. If it were the sun and our Earth's temperature were going up, this is the Earth's temperature. It wiggles up and down from year to year, but long term it goes up. If it were the sun causing us to warm, we're going to do this poll the very old-fashioned way. I'm going to ask you to actually stick out your hand. Stick out your hands. Yep, for real. Thank you. If it were the sun, does that mean the sun's energy would have to be going down to make us warmer or going up to make us warmer? Give me your thumbs. Up or down? You're looking at each other. The majority's right. It is up. Yes. Why? Because imagine you have one of those lights that have like the dimmer switch and you turn the dimmer switch up. You have to turn it up. It gives out more light. It gets hotter. So if we're getting warmer because of the sun's energy has to be going up too, right? Is it? I'll show you the data. The sun's energy has an 11-year cycle. It's a sunspot cycle that was actually discovered by Galileo over 400 years ago. But if you look at the long-term average, it's going down. So we should actually be getting cooler right now, not warmer if it's the sun. So could it be natural cycles? Well, there's two types of natural cycles. And people often don't realize that the people who study natural cycles are climate scientists. In fact, if you looked at all the climate science that people have done over the past 30 or 40 years, I'm willing to bet that more of it was looking at natural cycles than looking at what humans are doing to climate. We're the ones who study natural cycles. And we know that there's two types of natural cycles. The first type happens inside the Earth's climate system, so inside the atmosphere and the ocean. These cycles are like a teeter-totter or a seesaw. What they do is they just take heat and they move it back and forth, north to south, east to west, and more often than not, ocean to atmosphere and back again. One of the most well-known natural cycles like this is called El Nino. Who here has heard of El Nino? Anybody heard of El Nino? Just about everybody. It's hard to live in Texas without hearing about El Nino because when it's an El Nino, we get a warm or a wet winter. When we get a La Nina like this winter, you know what we get? We get no rain. Why? Because during a La Nina, more heat is going from the atmosphere into the ocean. And then during an El Nino, more heat is coming from the ocean out into the atmosphere. So if our planet, if our atmosphere were getting warmer because of one of these natural cycles, that heat would have to be coming from somewhere. You can't just create heat out of nothing. And the number one place it'd be coming from is the ocean. So instead of looking at temperature, what we can do is we can look at the heat content. So if the heat content of the atmosphere is going up, right, to be caused by a natural cycle, what would have to be happening to the heat content of the ocean? Give me your thumbs. There you go. Okay, yes, you were right. Down. We're doing this the old-fashioned way and the new-fashioned way. So let's look at the data. Here's the data. This is the change in the heat content of the Earth system in exajoules. You know how many Twinkies that is? Pretty much the whole campus full, probably more. This here is the change in the heat content, not just the atmosphere, but the land and ice put together. So it's going up. Yes, you'd expect it to be going up because temperature is going up. But this is the ocean. It isn't equal and opposite. In fact, 20 times more heat is going into the ocean than the atmosphere, the land, and the ice all put together. So it can't be a natural cycle because natural cycles just move stuff back and forth. The entire system is warming. So then we say, okay, well, there's a second type of natural cycle, though. And this type of natural cycle is really interesting. It is caused by changes in the orbit of the Earth around the sun. These are the cycles that bring the ice ages and the warm period like we're in today. Over time, the Earth's orbit gets more circular, and then it gets more elliptical. And also, the axis of rotation precesses like a top when you spin it. Do you ever spin a top when you're little? You know, it spins really fast, but when it's spinning fast, it also rotates slowly. That's precession. So what happens is the part of the Earth that's facing directly to the sun changes over time. Sometimes it's more water, sometimes it's more land, which means it absorbs different amount of energy from the sun. Could we just be getting warmer after the last ice age? Because, as you know, there was an ice age that ended when a squirrel was chasing a nut and broke off a piece of ice, and not really. Well, if we look at what's been happening to our planet over the last few thousand years, over the course of human civilization, really, on this planet, actually, what was happening was our Earth's temperature was, believe it or not, very, very, very slowly going down. Because if you calculate where we are in orbital cycles right now, and you can calculate it using geometry and algebra, we should be heading into the next ice age sometime in the next 1,500 years. Now, is that a good thing? No, because during the last ice age, half of North America was covered in about a mile of ice. We don't want another ice age. What is the perfect temperature for the planet? The planet doesn't have a perfect temperature. It can go up and down and it's fine. What's the perfect temperature for us? The temperature that we have had over the last few thousand years when we built all our cities and parceled out all our land and developed agriculture and built our infrastructure. The perfect temperature for us is just right. And so here's the irony of it. If you look at what was happening, if you analyze this temperature very carefully, it was not going down linearly, it was starting to flatten out. Why was it starting to flatten out? Because of the development of agriculture and deforestation. Agriculture changes the amount of carbon that's stored in the biosphere, and we also had a lot of cattle and sheep and goats that produce a lot of heat-trapping gases. The majority out the front end, actually, believe it or not. I know you're probably thinking of some of your relatives. That's the majority out the rear end. But no, cows and sheep and deforestation were actually starting to level us out and keep us at just the perfect temperature. And then what happened? Something happened, and that is our clue on where to look next. Because rather than going down, we are now going up. So all the natural suspects at this point, they have an alibi. It can't be the sun, because we should be getting cooler, not warmer. Can't be natural cycles because the whole planet's warming. It's not just moving heat back and forth. And it can't be the Earth's orbit because the next thing that was coming was an ice age. So now we can finally say, okay, if it isn't the sun or natural cycles, what is it? And we saw the clue on the previous slide. During the Industrial Revolution, we dug up and started burning a lot of coal and gas and oil. And when you burn coal and gas and oil, it produces something called carbon dioxide, which is a heat-trapping gas. Why does carbon dioxide matter? I have a little video that explains it. It matters because our planet already has an amazing natural blanket of heat-trapping gases. Totally natural. The sun's energy shines down and goes right through this blanket like a window. Then the Earth heats up and gives off heat energy, and that heat energy is trapped by the blanket, keeping us over 60 degrees Fahrenheit warmer than we would be otherwise. In fact, if we didn't have this natural blanket, we would be a frozen ball of ice and there would be no life on this planet at all. So what's the problem if it's totally natural? The problem is that by digging up and burning a lot of coal and gas and oil, we are wrapping an extra blanket around our planet that it doesn't need. And just like when I used to stay at my grandma's house when I was little, and my grandma would sneak in every single night and put an extra blanket on me because she was afraid I'd freeze to death. And I would wake up sweating, saying, Grandma, I didn't need the blanket. In the same way, the extra blanket we're wrapping around our planet is trapping too much heat. It's taking something that is totally natural and it is adding to it. How long have we known about this extra blanket? We've known about the extra blanket we've known about the natural blanket since Joseph Fourier in the 1820s. How long have we known that humans could wrap an extra blanket around the planet? Since Tyndale in the 1850s. Yes, we have known that humans were wrapping an extra blanket around the planet since the 1850s. These are real pictures. These are not like fake old-timey pictures where your family dresses up like they're from the Wild West. No, these are real pictures of these guys. How long have we known how much the planet would warm and the fact that the Arctic would warm twice as fast as the rest of the planet? We've known since Arrhenius in the 1890s. And how long have we known that thermometer measurements all around the planet showed that we were warming? Since this guy, his name is actually Guy Callender, he wrote in his spare time to people all around the world and said, hey, do you have any long-term thermometer data you can send me? I want to add up all of the thermometers around the world and see if we're getting warmer. 1938, he published that. So why is climate changing? The science says it's got to be levels of heat-trapping gases, the extra blanket we're wrapping around the planet, because we've looked at everything else, and everything else has an alibi. Now, if you have more questions on the science, this is an excellent website. It's called Skeptical Science, and its motto is because every scientist is skeptical, which I love. It's totally true. And they have everything organized. If you go to the arguments there, like the second link there beside home, they have every single argument laid out in order. And they have short answers, they have medium answers, and they have super long answers. So this is a great website, and they even have an iPhone app. But now we're going to ask another question, which is personally a very fascinating question to me. Well, where does all the stuff come from that we hear in the news every day? It's just a natural cycle. We haven't studied this long enough to be sure. Scientists are making the whole thing up. Sea levels are actually going down. It's such a tiny amount of CO2. And my favorite, it's cold outside. I'm going to take a little diversion from the science now to offer you 5 signs of fake news. This can be applied all across the spectrum, but I'm going to give you 5 examples of what this looks like when it comes to climate change. Okay? The first one is actually my favorite, conspiracy theories. Don't you love conspiracy theories? They're so interesting, but they're usually not true. Conspiracy theories on climate change are so frequent that they have their own Wikipedia entry. Yes. They are so frequent that I get them on Twitter every day. Every day. No kidding. These, I'm going to show you a couple, are from one day. One day last week. It's propaganda, a tax grab, and a huge scam. This is just a money grab. I did not edit these for grammar. This is just another money grab of different levels of government. What we do deny is your tax scam, blaming Mother Nature. You're a fraud that has no facts, only a narrative. And some of you may know we do this little PBS series called Global Weirding. My personal favorite video of Global Weirding is it's just a money grab by the scientists, right? And that's a cartoon of me with my giant plate of government money that I'm taking into my secret lab. Conspiracies suggest that every single scientist in the entire world, including all of NASA and all the scientific agencies in the entire world, have colluded on a global conspiracy since the 1850s. But no one knows except for a couple of people on Twitter. That's the conspiracy. Going with that, often, are the fake experts. Now, the fake experts might sound very credible. Here's an example of fake experts. 49 former NASA, right? NASA scientists send a letter disputing climate change. Here's a second headline about the same letter. Just because you work for NASA doesn't necessarily mean that you're the best at that. So imagine if you know a physician who is a great physician and they're the perfect person to set your leg when you break it. Imagine you get a letter from the IRS that says, something is wrong with your tax return and you owe us thousands of dollars. Are you going to run to the best physician that you know, or are you going to go to your accountant who is absolutely fantastic at figuring out tax laws? If you're smart, who are you going to go to? The accountant. Thank you. Why? Because what you're an expert in matters. And so when you hear people saying things about climate change that sound a little funny, or about anything that sounds a little funny, the first thing to do is Google them. Figure out who they are, who they work for, what their expertise is. And this works for anything. They're usually, if somebody is saying something in the news, there's usually a Wikipedia article on them or some type of page that explains who they are and where they come from. It's really important to check, because the reality is when you ask people who actually know what they're talking about, at least 97, this is actually an old number from almost 10 years ago, now it's more like 99, at least 97 out of 100 people who actually know what they're talking about say, not only climate is changing, not only humans are responsible, but we're the number one reason why it's changing. Then we get to impossible expectations. And my favorite impossible expectation between November and April is, if the planet is warming, it will never be cold. Of course, it will be cold because there's this thing called winter. And this is one of my absolute favorite headlines. I love this headline. Global temperatures plunge. Icy silence from climate alarmists. You're in the front row and you have glasses. Tell me, what is the date? What is the month and the day? Can you see that?
It is the 30th of November, about 2 years ago.
Okay, the 30th of November. What season is just starting around the 30th of November?
Winter. Winter.
Exactly.
The season of running.
Isn't that hilarious? So, yes. So saying that it's cold here, so the whole planet can't be warming, is saying the ship can't be sinking because my end just went 200 feet up in the air. You have to look at the whole ship. You have to look at the whole planet. You have to look at the whole thing over climate timescales, remember? Not a single day, at least 20 to 30 years. Now, let me offer a word of caution. If you've been following the news, and I was actually just doing a BBC interview on this right now, that was why I came in just a little bit late. If you're following the news, you know that we've seen headlines about this. Does one warm week in the Arctic prove global warming? No, it doesn't. That's a tree, right? So when the BBC had me on half an hour ago, they said, is this global warming? I said, one warm week doesn't prove it. But I said, what we can do is we can look at heat waves in the Arctic and we can tell you that over climate timescales, they are becoming more frequent and they're becoming stronger. But it caught everybody's attention because this past week, all of Europe, except for southern Spain and Italy, was warmer than northern Greenland. Isn't that crazy? Mm-hmm. We are seeing these heat waves happen a lot more frequently, and every time they happen, they're getting stronger. But we have to look over climate timescales. Then we have misrepresentations and logical fallacies. Here's my favorite one. My favorite one is this. If you look at the composition of the atmosphere, our atmosphere is 78% nitrogen, 21% oxygen, and you know how much of it is carbon dioxide that makes this like blanket we're wrapping around the planet? 0.04%. So people say, it's just a tiny amount. How could it make a difference? Why is this a logical fallacy? Because this is just a tiny amount of white powder. I'm just going to put a little pinch of it in your drink. It's arsenic, but it's only a tiny amount.
But it's still enough to kill it.
Exactly. Because it is not the amount that matters. What is it that matters?
The composition.
Exactly, the composition and the potency. When you take an antibiotic, do you take an antibiotic that's the size of your body? No, of course not. It isn't the size, it's the potency that matters. And this is a logical fallacy to say it's only a little bit, it doesn't matter. I'm always tempted when somebody says that to me to actually pull out a baggie of white powder, but I think that might be taken the wrong way. By the way, this is actually a picture of flour, if anybody's wondering. It's really not arsenic. See, I even avoided arsenic in the pictures. And then we get to the last one, which is cherry picking. Now, cherry picking has nothing to do with actual cherries. What it has to do with is picking one little piece of information that proves your point and ignoring everything else. So it's kind of like saying, well, my great aunt Lulu smoked a pack of cigarettes a day and she died at age 96. She never coughed, she never got lung cancer, she was fine, so therefore smoking is fine, right? What did I just do? I picked one person who serendipitously had the healthiest pieces, healthiest lungs in the entire world ever. Picked one person and I used her to extrapolate to the whole population. What do we know? We know that smoking increases your risk of lung cancer, right? We know that. Not for everybody, but for the majority of people. So what's an example of cherry picking that we often hear? We often hear, well, those Vikings went to Greenland. Why did they call it green if it wasn't green? It must have been very green back then. What's really interesting is, back then, it's true in the medieval times. Now you might say, how do we get temperature in the medieval times? We get it from natural thermometers like tree rings and ice cores and even historic records. It is true that back during that medieval time, there was a warm spot over where? Over the North Atlantic. And that actually enabled the Vikings to get all the way to Greenland. Now, what's so fascinating is, was Greenland covered in ice in the Middle Ages? Yes. But nobody wanted to move to Iceland. That name was already taken. But they would move to Greenland, so they called it green. And by the time people got there, it was too late to get back. It was the first known example of really good PR marketing. Now, it was a little bit warm, but what happened in other places? Other places were cool. This is a classic example of that teeter-totter seesaw I was talking about. The teeter-totter seesaw natural cycles, they put some heat over here and they take it away from here. This is what it looked like back in the medieval warm period. Do you know what it looks like today with the same temperature scale on the bottom? I'm going to show you today. Isn't that crazy? So it is totally cherry picking to pick just one little piece. So next time you see any of these, you know that they come from the fake arguments. But now we get to question number 4. If anybody's wondering, there's 5 questions. I'm not going to keep you here for hours. Question number 4 is, so what? If you were going to design the cover of a textbook on global warming, and you had to pick a picture to go on the cover, your phone's out, here we go. If you had to put a picture on the cover, what would it be a picture of? What do you think is the most common image that the most people would just look at that textbook and be like, oh, I know what it's about because I picked a picture of blank? Enter what you would put on the cover. Just write it out and text it. I don't know who Gina is. All right. We are seeing a lot of really cool examples, actually, but we are seeing one thing come to the fore here. And what is that one thing?
Polar bear.
It is a polar bear. The number one image associated with a changing climate is a polar bear, usually looking lonely and looking sad and looking hungry.
Well, I'd be that way too if I was duck.
Exactly. And then they are. Now, I want to ask you, how many people here have actually seen a polar bear in real life, in the wild? In the wild. Got 2 of us. All right. So here's my question to you. If the number one reason we care about a changing climate is the polar bear, who cares? Us. Maybe. Right? But the reality is we care about the polar bears, and the polar bear scientists actually told me this. I'm quoting them directly. We care about the polar bears because after the polar bears, we're next. And I don't mean that we'll get eaten by the polar bears. This man did not get eaten.
I thought you were implying Coca-Cola. No, I was just saying because
True.
Coca-Cola might get like global change, and they had a polar bear during the winter saying that you bought it, they'd donate $1 for each can to polar bears. Like,
Which is cool, yes. But now, actually, you might have seen this before, polar bears are starting to move south and they're starting to breed with grizzlies. And so they now have something called like a pizzle bear, which I think is a disgusting word for them. Okay, why are humans so vulnerable? We know that we live through conditions all the time where it gets cold and then it gets hot, right? It gets wet and then it gets dry. And if you live in Texas, it looks more like this, doesn't it? Right? Yes. Okay. Let's leave the polar bear side here. Who has ever gone into a class or a movie theater and it's 95 degrees outside and you walk out 2 hours later and it's like 50 degrees or 40 degrees and even sleeting? Yes. Okay. We live in a place that has crazy weather, totally naturally. We see years that look like this. These are all pictures taken from around Lubbock. We see water supply that looks like this. We see wildfires that look like this. This is from 3 hours west of here. We see dust storms that are so crazy they give them fancy names like haboobs. This is our football stadium. And then the year after this crazy dust storm, you know what our football stadium looked like?
Flooded.
It was flooded. And this is the Marcia Sharp Freeway just outside.
Oh,
Yeah. And we had really good crops that year. So when they had a competition 5 years ago now, they had a competition for the toughest weather city in the whole United States. Guess who won? Yes.
oh my.
Okay. Now, this is what I don't understand, because if you're having a conversation with somebody who you don't know all that well, what do you normally talk about? The weather. Okay. So the weather is the number one topic of conversation you can have with people. And we have the craziest weather in the whole country. So that's why I can't believe that the same year they had this competition, they also had another competition that we won. Okay, how does that work? We have the most to talk about of any city in the entire country. I think there's a little bit of bias going on there, personally. All right, so if our weather is crazy like this, why do we care if it changes a little bit, right? It's because our entire society is built on an assumption that we don't often think about, and it's the assumption that we can have crazy hot and cold and wet and dry weather, but it all averages out. What things are built on the assumption that not only that it all averages out, but also that we know what the range is going to be from looking at historical records. We have built and designed our homes based on this. You know, what type of insulation, what type of windows you put in your house, how big an air conditioner you get. That's based on past conditions. We have figured out what type of crops we can or can't grow based on past conditions. This is a big one. We've outlined our flood zones. You know, they have a 100-year flood zone. They have a 500-year flood zone. In Houston in August, were people flooded if they lived outside the 100-year flood zone? Were they flooded if they lived outside the 500-year flood zone? Why are the flood zones not accurate anymore? It's because they're based on what? Historical data. We even build our state and our city water plan based on historical data. But what happens if we still have the ups and downs? Of course, that's a natural part of our weather. But what happens if the long-term average is changing? And even worse, what happens if the variability is changing? The way I think about it is this. Everybody know where this is? Please, yes. We live in a very flat part of the country. We live in a place where the only type of mountains we have are upside down mountains, canyons. You know, you're driving along and all of a sudden there's a canyon. Our roads are so straight that you could drive a good ways north on I-27, not only staying on the highway, but even staying in your own lane if you're driving up I-27 towards Plainview looking in the rearview mirror. Think about it for a minute. Why does that work? Because the road is dead straight. So where you're going to be in 30 seconds, a minute from now, can be perfectly predicted from where you were a minute or even 5 minutes ago. Right? No, I don't recommend it. Don't do it, okay? But it would work because the road is so straight. It would work, that is, until you get almost to Plainview. Who has seen this? Anybody remember this? Almost before you get to Plainview? Yes. There's this giant curve in the road, and there's those concrete grain silos right on the curve. Now, everybody please, what happens if you're driving up I-27 looking in your rearview mirror when you get to the curve? Thank you. Yes, exactly. You're going to end up where you didn't want to be. Why? Because the past was no longer a perfect predictor for the future. So planning for the future based on the past is like driving down the road looking in the rearview mirror. It works great when the road is straight and when climate is stable. When there is a curve in the road or when climate is changing, it does not work so well. So why do we care about a changing climate? We already know that we get crazy weather disasters totally naturally. In fact, if you add up all the billion-dollar weather and climate disasters that have happened in the entire U.S. since 1980, you know what state is number one?
Texas.
Exactly. Why is that? Because we get it all. Why do we get it all? Because of where we're located. Gulf of Mexico, middle of the continent. What all do we get here? Let's see if we can fill my fingers. Okay. We get dust storms. What else? Tornadoes.
Flooding.
Hurricanes and flooding. Yep.
Droughts.
Droughts, exactly.
Yeah, Midland had drought.
Yep, we get
Snow,
droughts.
blizzard.
Blizzards, yes.
Blizzard.
Most people don't realize we get blizzards, but we get bad ones. Yes. We get hailstorms, exactly. We also get crazy thunderstorms, right?
Torrential rain.
Torrential rains, yes. And we also get straight line winds too, right? We probably get a few more. We get pretty much everything. The only thing we don't get, I think, is like glacial lake outburst floods. So we are already in the crosshairs when it comes to naturally occurring weather and climate disasters. Why do we care about a changing climate? Because it exacerbates the risks we already face today. Think of it this way. There's always a chance of rolling a double six if you have a pair of dice, right? So there's always a chance of a Hurricane Harvey, naturally. What a changing climate is doing is sneaking in and replacing some of those numbers on the dice with sixes. So now you roll the dice again, the chances of rolling the double six has gone up. The chance of a Hurricane Harvey happening today is now 1 in every 10 years. The chance of a Hurricane Harvey happening 100 years ago was about 1 in 100 years. The chance of a Hurricane Harvey in the future, if we continue on our current pathway, could be 1 in 3 years. It's weighting the dice against us. You could always have a Harvey naturally. You could always have a drought naturally. You could always have a flood naturally. It's just part of life. But the dice are getting weighted against us. And why do we care? We care because, what is this map again? This is the map of billion-dollar weather disasters. Costs us money. Damages our homes. Affects our economy. So here's our last question. Our last question is, what on earth can we do? Now, I'm probably going to surprise you, unless you've heard me talk before, because I'm not going to tell you to recycle or change a light bulb. The number one most effective thing that we can do about this problem goes back to the polar bear here. If you think it's all about the polar bear, then why would you care? The number one most effective thing we can do is talk about it. Because they did a survey and they asked people, they didn't say, do you talk about it? They said, do you hear somebody else ever talk about this? Guess what? 75% of people said either a couple of times a year, once a year, or never. Why? Because most conversations that we imagine having, or most conversations that we might have, tend to look something like this, right? All right. So I'm going to ask you, honestly, since this is anonymous, get out your phones. Okay. Would you rather, you ever played that game? Would you rather take a test, A, so just put in A if it's take a test, B, have a tooth pulled, C, wear the sweater your grandma made you to class or work, or D, talk to someone you know about climate change? Here you go. A, take a test. B, have a tooth pulled. C, wear the sweater your grandma made. Or D, talk to somebody you know. You can be honest because I don't know what you're answering. Oh, wow. Look at that. Okay, so people actually feel like they can have a conversation now. That's good. I should have asked you this at the beginning and see if the numbers changed, right? Okay. So for the third, it's about 2/3, 1/3. For the third of people who are not so sure about the whole conversation thing, and then for the 2/3 who are willing to have a conversation, but only because the other things are too unpleasant. Again, the main reason why we don't want to talk about it is because we're afraid it's going to end something like this, right? But here's the interesting thing. If we can't agree about politics, and as long as there's 2 humans on the planet, I don't think we will ever agree about politics. And even if people can't agree about the science, did you know that the majority of us already agree about the solutions? I'm going to show you proof. The same people who did this survey, they did a survey across the whole US where they asked people, do you think global warming is happening? And anything that is orange is more than 50%. It turns out everybody does. So you can talk about, hey, we have fire ants here we never used to. Our plants and stuff are flowering earlier in the year. Our weather disasters are getting crazier. We can talk about this stuff because almost everybody agrees. Do you support requiring your utility, like LP&L, to produce at least 20% of their electricity from renewable sources? Guess what? Everybody does. And did you know here in Texas, we get 18% of our energy from wind already? Do you support setting strict CO2 limits on existing coal-fired power plants? Everybody does. Do you support funding research into renewable energy? This is 80 to 90%, even 95 in some places. What's happening here in Texas? I love talking about what's happening here in Texas. In fact, we even have a Global Weirding episode that's just about Texas. So if you want to talk about Texas, check out our Global Weirding episode. Let me give you the highlights. We have in Texas, we have the biggest Army base in the US, Fort Hood. Last year, Fort Hood signed a new electricity contract, and this is a picture of it right here. They signed a new electricity contract for wind and solar energy. Why? Because it would save taxpayers $150 million over natural gas. That is a great thing that you can have a conversation with because who doesn't want the government to stop wasting our money, right? Hopefully everybody. Georgetown, little town north of Austin, 3 students at the local college in the business program had to do a project on the city's energy. They ran the numbers and they figured out that the city would actually save money if they invested in solar and wind energy compared to natural gas. So they took their results to the city council and they showed them how green it would be to go green. And when I say green, I mean money green. The city decided they would do it. They became one of 3 cities in the whole country to already go 100% clean energy to save money. And then every year we break records. This year our record was 24% of our electricity in the first quarter of this year was wind. We've got 25,000 jobs in the wind energy industry in Texas. Around the whole country now, there are more jobs in the solar energy industry than the whole coal industry in the whole US. And the Museum of Coal Mining in Kentucky put solar panels on their roof last year to save money. These are cool things that we can talk about, right? What else can we talk about? I always look for these good news stories to post on my Facebook page. So 2 of the most popular stories that I post about are the fact that now you don't have to put solar panels on your roof anymore. You can put solar shingles. That's a picture of solar shingles. Isn't that crazy? And the solar shingles come with a power wall that you put on the wall of your garage. If you look into that picture there, you see the white thing on the garage wall? That's a power wall that costs $3,500. It will store all the energy you generate from your roof, so you don't even have to put it back in the grid. You have it in your house, and you can plug your car into it. One of my friends, a guy called Phil, was having his power wall installed today, and he sent me a picture of it. And I was like, oh, I'm so jealous. You can plug in your car. I got a plug-in car. Now, the battery doesn't last super long. I really wish Texas Tech would install a power outlet for me. But I charge it up at home. I drive to Tech. I drive around town. I drive home. I average 80 miles per gallon because as soon as the battery runs out, it switches to gas. I go to the gas station once every 2 or 3 weeks. I love it. We can talk about this, right? Now, Some of you might be thinking, yeah, that's all well and good, but what about... Yes, exactly. Because when we look at pictures of China, this is what we see. Here's the thing. We've heard that China is building a new coal-fired power plant a day, right? You heard that stat? It was. Did you know that China, for this year, I calculated this myself, for this year, China has been shutting the equivalent of one coal-fired power plant a day? Why? Because they're replacing it. China has more wind and solar energy now than any other country in the world. They are flooding coal mines, open pit coal mines, flooding them and putting floating solar panels on top. Why? Because it's cheaper and it doesn't kill people. Did you know that burning coal and oil and gas is responsible for 2.5 million deaths around the world every year, including 200,000 in the US? 200,000. 200,000 people in the US die every year from breathing in the pollutants from burning fossil fuels. Now just stop for a minute and imagine if terrorism killed 200,000 people in the US every year. What would we be doing? We would not be investing in the terrorist industry. We would be shutting it down. Yet we are investing in the coal industry, even though there are more jobs in solar energy, and even though investing in coal at this time is like investing in horses and buggies after they're already producing the Model T Ford. Now, people say, well, so what's happening to coal miners? And these are some of my favorite stories. Did you know that, get this, a Chinese wind company went into Wyoming and offered coal miners, US coal miners in Wyoming, free retraining to start installing Chinese wind turbines in the US? Why is the US not doing that? That is the question to discuss. Now, I would add, though, that there's actually a company in San Antonio, an American company, that is taking in oil patch workers who lost their jobs when oil prices tanked, and they're training them to do solar panel installations. The cool thing is that China aims to spend at least $360 billion on clean energy by 2020, and the US needs to catch up because they are currently behind. That is a conversation to have. So I hope you can see, through the few things that we've talked about here, that, the conversation might not end like this, but at least it won't end like this. Because there are a lot of cool things we can talk about. Because the bottom line is, we all want clean air to breathe. We all want clean water to drink. We all want healthy food to eat. We want a safe place to live. We want a healthy economy. We all really do want the same things when it comes down to it. So what I would encourage you to do is think about what you can talk about. And if you want more ideas, our Global Weirding series, which you can find on YouTube, is these super short little videos, about 5 minutes. They will give you lots of things to talk about. So use the videos and spread the word. Thank you.